everyone. I hope you're doing well. We get to do a reaction stream, so those are always exciting. Uh, Oops, there we go. Hit the button. People always ask if it ever gets old seeing your puzzles on Cracking the Cryptic, and at least for me, I can say it has definitely not gotten old. It is still one of my very favorite things to have happen. So I'm excited to get to watch this with you all. So if you're new around here, by the way, or if you're watching this or whatever, I do stream regularly. I usually solve puzzles, although I actually set a puzzle on stream recently. So that was also pretty cool. So, but not this puzzle. This puzzle was before that one. Tomorrow I am streaming, although I will tell you now I'm going to stream Animal Well tomorrow, so we'll see how that goes. I am doing a little celebration because my semester teaching is done, so I'm going to stream a video game, which I do every now and then, but not too often. Usually it's puzzles, but the game has puzzles in it, I'm told, but I don't know anything, so I'm just going to go in blind and enjoy it. So that should be fun. All right, so we're going to watch Simon solve words. We're going to watch Simon solve Zag. So just the basic idea was, can I do anything interesting with arrows and 10 lines? And it turns out that yes, I could do some interesting things with arrows and 10 lines. So we'll get started with the video. Let me know how Simon's volume is relative to mine. Ooh, Plonk Time has gifted 10 memberships. Let's see who gets them. Daniel, Nicholas, Oddly Even, David, Jay, Zamina, Sue, AM1028, Crangoon, DM Dugo. Thank you so much to Plonk Time. Let me get you a donation dance.
Hello and welcome to Saturday's edition of Cracking the Cryptic, where we have a puzzle for you today.
Thank you so much, Plonk Time. Means a lot. And enjoy your memberships, everyone. You've got some cool emotes in there.
Zetamath, and a puzzle called Zag. Now, when I saw that this was being suggested for me today, I was a bit confused because I thought I'd done a puzzle called something like Zag by zetamath before.
I will confess, I did go back when I thought of calling it Zag. I did go back and make sure that I had not called a puzzle Zag before, because I thought I had, I thought maybe I had, but I couldn't remember one, and at least I haven't found one, although if it turns out that this is the second puzzle I've called Zag before, well, if you've watched the stream, I've solved the same puzzle like 3 times on stream before, so it's very possible there will be repeat names in the future.
A quick look at zetamath's back catalogue, and I checked our back catalogue as well, and I'm sure I haven't done this. It's just ringing a weird bell with me. So anyway, this is what I'm going to be doing. It's basically a 10 lines puzzle. This orange thing here is a 10 line. So if you're familiar,
I haven't done a Zig. The inevitable prequel to this puzzle will be called Zig, I'm sure.
As well, but nothing more complicated than that. 3 stars out of 5 for difficulty on Logic Masters Germany, and the usual 95 or something % approval rating.
I think the fact that we sort of the difficulty has crept to the point where this is now like a 3-star puzzle is a little bit crazy. I think this is I think this your difficulty rating is really skewed if this is 3 stars, because I think this puzzle has some teeth. Like, I'm surprised it's not 4, given the sort of the peaks. Although there are a lot of parts that are that are solid. Like if it had kept with the opening, I think it would have been solidly 3-star. But I got fancy in the middle.
That you'd expect from every single puzzle by the great man. So this is what we're going to be doing in today's video. After I have told you about a couple of exciting things, I'll start off with a picture that I took last night. There you go. I hope you can see that.
So cool. We could not see it from our house last night, but I'm hoping we can tonight.
House last night. Can you believe it? The Northern Lights made an appearance in Surrey. A few years ago, I went on a special trip to Lapland with the express sort of purpose of seeing the Northern Lights, and no Northern Lights were to be seen on that trip, which was a great disappointment. So I can't tell you how extraordinary it was. I nearly missed them as well. There wasn't sort of a big hoo-ha here in the UK about them being there last night, but I was about to go to bed. I looked at Twitter and hashtag
occasionally look
Aurora was
outside.
trending. I thought, why is hashtag Aurora trending? And Brian Cox, the sort of physicist stroke rock star, had tweeted some of his own pictures from Surrey. So I immediately went outside, and there we go. So, and apparently it might happen again tonight. So I'm definitely.
It would be
going
very
to have a
cool if
look
I got to see it. I
outside.
think I've seen it once
thanks
before.
Also to Peg, who also dropped me an email telling me this might happen.
Oh, Maverick is here.
So
Excellent.
Just blown away by that. And if I get any more good pictures, if you're following us on Twitter, I shall send them there later on tonight at Cryptic Cracking, of course. Now, next, there's going to be a bonus video on the channel tomorrow. It's going to be a crossword video in which I solve a puzzle by the great and very funny Steve Pemberton. Now, some of you may know Steve from Inside
I was going to say, isn't
9.
Steve the one that is on
amongst other
Taskmaster?
things, I think Steve has been a writer on Doctor Who for years as well. And Steve was on Taskmaster, the quiz show, the other day, talking about something like things that... What is one thing that you would say people should get into? And Steve said, people should get into cryptic crosswords, and Steve is right. And to prove that point, Steve had actually set the Guardian cryptic crossword for that day, and sort of encouraged the audience.
I do really love Taskmaster,
and I had a go at it, and I can tell you it is spectacularly good. It also contains some extra thematic material that I discovered at the end of the solve, and it is it's just tremendous. So if you have any interest in cryptic crosswords at all, check that video out. That will come out tomorrow morning on the channel, UK time, 10 o'clock, I hope, providing I've done the editing by then, which I fully intend to have done. Other things to talk about. We've got all our stuff going on over on Patreon, the Glum Hippo Sudoku.
There we go. So Selena pulled the rating down to 2 stars. That makes sense.
Some birthdays to do today. So let's say happy birthday to Amy from your fiance, Akos. I know the two of you are getting married in August, so not long now. And down there in Sydney, Australia, I think. And apparently you enjoy watching the channel to relax after a day of stressful wedding preparation. So thank you for watching, and Amy, many happy returns. Next to Kevin, who's turned 53 today. And I remember you, Kevin, from last year because you live in Gun Barrel City. And I couldn't believe there was a place called Gun Barrel City, but there is.
It'll be gas in an hour. Yeah, that's true.
And Kevin, many happy returns.
I am told there's a thing where once Simon does a puzzle, often it makes it go down a star on LMD. So maybe it will be down to 2 stars by the time a bunch of people discover that it's very easy to copy the solution from the grid at the end of the CTC video. Like that might only be 1 star in difficulty. I'm not sure. Although I think the solution code to this one is a full 9 digits. So it's a lot harder to copy the solution code for this one than it is to copy the solution code for Yazi, which is, spoiler, only 6 digits. Because I love having very short solution codes. It is my is one of my things.
I hope I'm saying your name correctly, Rochelle. You've turned 22 today, and I know this because your partner Kyra wrote to us. I think you're over there in the Netherlands, if I'm not mistaken, and I am told you are getting white chocolate cake today. Now that could be spectacularly good. That really could.
I mean, I don't think there's anything wrong with watching a solve and then rating it on LMD. I mean, you've experienced the puzzle by the time you've watched Simon solve it. If you want to rate it, by all means, go ahead. I think it would not be the worst thing I know that people regularly do on LMD. I'll just put it that way.
Send me a picture if it is spectacularly good, just so that I can be jealous. And next, I'm going to say Veronica. I hope I'm saying your name correctly, Veronica, and you have turned 22 today. And I know this because your sister Aurelia wrote to us and said you'd appreciate the shout out. So many happy returns. I hope you get chocolate cake, white white or dark chocolate cake or milk chocolate cake, all are fine, providing there's enough icing, of course. And the only other thing I wanted
Icing
to
is
say is
delicious.
to thank Rhett for sending us a kind email down there in Australia. Rhett, thank you very much. We did appreciate it. Now, let's turn our attention to solving some Sudoku and have a look at Zag by zetamath. These are the rules. Normal Sudoku rules apply. Digits along the orange line must be broken into one or more contiguous groups of cells that
I love
each
that
sum
it
to
said
10.
one or more.
Such groups
Did I really say
overlap.
that? I don't know.
Digits may repeat within such sums if
It would be a very big surprise if it turned out to be one. I'll just say that.
allowed by other rules. For example, 513 173 is a valid fill for a 6-length line because it can be broken up into 5131 and 73, each of which sum to 10. So let's stop there and make sure we understand how this line works. So basically, we're going to have to divide it up into pieces. So let's just have a go. Oh, terrible, terrible, terrible choice of colour. So we could do something like this. This may well be right because there aren't that many ways of filling 10 lines. So forgive me if this is right. But basically, if this was the correct way of splitting
I can
the line
confirm
up,
this is not
then
correct.
those 3 would add up to 10, these 2 would add up to 10, these 2 would add up to 10, those 4 would add up to 10, these 3 would add up to 10, etc., etc. So basically, it's a very natural rule, but it's really easy, in my experience at least, to make mistakes, especially when you forget about the possibility of things being repeated on the line. So if you look at that little section there, that looks like it's absolutely waiting for me to fall into a trap, because it might be possible to have sort of 2 repeats on the.
He says it's really easy to make mistakes. I'm trying to remember if there's any 10 lines puzzles that I remember Simon making a mistake with. The first 10 lines puzzle, that one definitely is designed so that you're almost positive you've broken the puzzle like 5 minutes into it. And Simon definitely had the experience of saying, oh, I've definitely broken the puzzle when he did the intended thing and then understood why it was not actually broken. But I can't remember him breaking others, and I feel like he's done either all or almost every 10-line puzzle I've ever made. I haven't made that many of them. I'm trying to remember. Maybe he's broken other people's 10-line puzzles or something. I was wondering, like, did he break one so badly he didn't post the video or something? But if he did, I don't think it was one of mine. Maybe. I do agree they're very easy to sort of... they're very slippery things. Like, I've said this before, but 10 lines are definitely my favorite constraint that I've ever come up with. And they tend to lead to very narrow solve paths because basically they don't do... they do almost nothing on their own, which is great as a setter because it means you almost never break the puzzle with a 10 line. In fact, that was super, super helpful in the crazy puzzle we set a week ago or so, where we did a deconstruction with 10 lines, and it just had lines all over the place, and it felt like it was destined to break, but then it did not break because 10 lines are just so flexible, which I really appreciate.
Line and create all sorts of weird concoctions that actually add up to 10. There's only one more rule, which is that digits along an arrow sum to the digit in that arrow circle. So those 3 digits there, you add them up and you put the result in that circle. It's as simple as that. So let's do an example. If that was 1, 2, and 3, 1 plus 2 plus 3 equals... No, equals 6. That's a slip of the finger, not a slip of the mind yet. And that is how arrows work. Do have a go.
By contrast, arrows break exceptionally easily because arrows are an incredibly strong constraint, and so I broke this puzzle over and over and over and over again because the arrows kept breaking. And there was one step around box 6 that I wanted to set up with this arrow where I was so excited because it was just such a gorgeous step, and then it never worked because the arrow broke. Dagnam arrow.
So the way to play is to click the link under the video as usual. But now I get to play. Let's get cracking. Now, I'm going to take the low-hanging fruit, Zeta. I'm sorry, I am. So normally I would start by trying to divide the line. But actually, I think I'm going to start with the arrows here. Because 3-cell arrows are interesting if the digits on the arrow all have to be different. Because these have to be at least 1, 2, and 3.
I was just thinking that, Micro. I do love the I get to play.
There might be some maths we can do, actually, with box 1. We'll come back to that. That one's got to be at least 6 as well. That's 3 different digits.
It is the meta, by the way, that for my puzzles, almost always the correct place to start is box 1.
Is because of a secret. And it's a secret I share with only my very favourite people. But if you're watching this video, you're definitely one of my favourite people, so I'm very happy to share the secret. And the secret is to do with the sum of any complete row, any complete column, or indeed any complete box of a Sudoku. Now, because we know this box contains the digits 1 to 9 once each, because of the rules of Sudoku, we know those digits sum to 45. Now, my first thought there is that 45 is an...
Yeah, it is occasionally, as Paul Fly says, it's occasionally box 5 or box 8 for the break-ins of my puzzles. There are very few puzzles where it's not one of those. It's overwhelmingly box 1. I don't think I have any puzzles where the break-in is box 5 where it is not incredibly, incredibly strongly telegraphed that the break-in is box 5 or box 8.
Odd number. Knowledge bomb. Whereas the contents of this arrow are going to be in total even. And the way we can see that is, of course, we know those, let's say these 3 digits sum to x. Then we're going to write x in the circle, aren't we? In other words, the total contents of those 4 cells sum to 2x, and 2x must be an even number. Now, given that 45 is odd, we now know these digits sum to an odd number.
Paul Fly asks why I would ever use box 8 instead of box 2, and that's because going up feels a lot more natural than going down. It's the same reason why there's a lot of climbing video games, and there are not a lot of video games that involve going like straight down. There are a lot that involve going straight up. So it feels very natural to, if you're going to start in the center and build out, I think at least to me it feels natural to build up from the bottom. Starting in box 2 would feel really unnatural to me.
Which means that they don't exactly divide into 10 lines. So it's not going to be the case, we can say now.
Paul Fly says you go down from box 1, but my puzzles never go down from box 1. It's always from box 1 to box 2. It's always read left to right, top to bottom, if it starts in box 1.
For example, that we're splitting that line up into 2 segments like that, each of which adds up to 10, because that would make maths wrong. And maths, in my experience at least, tends to be right. So
I do love Spelunky.
What that means is...
Final stage of Fall Guys.
Well, okay, I now see what that means, because we can now think about how many different 10 sums we have to put into these 5 cells. And we've basically got a very narrow choice, given that, well, one secret of 10 sums, and it's a bit fatuous, but I'll say it, is that any 10 sum must be at least a 2-cell sequence, because you can't just write 10 into a single cell. Oh, somebody's going very fast. So
it's funny, that deduction alone is like one of the most powerful deductions in 10 lines, that every 10 sum has to be at least 2 cells. And it's like one of the things that like takes you a minute, even like in the first 10 lines puzzle, to notice. And it's certainly one of the things that I think is harder to figure out in Yazi, actually, the most recent one.
So the choices for how we're going to divide up this line are broadly, we could have one 10 sum, couldn't we? And then 2 digits that would add up to a maximum of 9. So that would be something like 19 there. And that can't be right, because the maximum size of this digit is 9, which means the maximum size of those 4 cells is 18, which means the minimum size of these cells is 27.
Do please like the stream, as Microstudy says. It is greatly appreciated.
At least 2 full 10 sums in here.
I'm glad you liked it, Naverio.
Because otherwise, numbers won't work again, will they? we're going to inflate that too high. So in fact, what we can say is that this line must be broken up into two sums, two complete 10 sums, some rump as the remainder, and that even the remaining rump is going to have to be fairly substantial.
He thought about this slightly differently than I did. My way of thinking about it was to note that if I tried to make this a 3-cell sum, then these 3 cells along the arrow, I know sum to at most 9, and these 3 cells would then, of course, sum to 10, but that would be 6 cells in a Sudoku grid that sum to at most 19, which is not possible because those 6 cells, which are all in a box, need to sum to at least 21. So I always thought of these steps in this puzzle as batching the arrow cells and the 10 sums together and using the whole triangular number trick, rather than using the box math trick. But the box math trick, of course, ends up being useful regardless. So like you end up, even in my path, doing the math he's doing anyway. But that was sort of my way of originally sort of thinking about this. Oh, also one thing I maybe should say about this puzzle, that may or may not be clear, is that when I originally started this puzzle, I was thinking that the solver was going to have to draw the line, that I was going to give the start here and the end here, and you were going to have to figure out how to make the 10 line sort of bend around. But it turned out that there were no interesting steps along that I found along that way, so I ended up just being happy with giving the line rather than making you draw the line. I've started a lot of puzzles with the idea that the solver was going to have to draw the 10 line, and I think so far I've never made a puzzle where the solver had to draw the 10 line. Technically, in Buffet, the solver has to solve a 10 or has to draw a couple 10 lines, but I've never made a puzzle where the entire puzzle was drawing 10 lines. But someday.
Yeah. So if those sums sum to 20, which they do, and then we add 9 on here, plus another 9 there, that's giving us 38, which makes this 7. But the interesting thing about that is that if I reduce this by just 1 and make it 8, then I'm increasing this by 2 effectively, because I'm increasing it by 1 for the circle and 1 for the arrow. So that is 7 or 9, and this is 8 or 9. So there is a 9 in one of these squares. That's the sort of zeta deduction that might matter.
That is a very zeta deduction, so although at no point in
9.
thinking about this puzzle did I notice that there was there was a 9 corner marked in one of those cells, I will admit.
8 in the other order.
Yeah, I agree with Jay. Now. Yeah, build your own 10 lines does turn out to be a pain.
So
I want to make it like a...
My next thought is about...
So one thing I've tried to make is like the 10 line is a country road line. I have tried to set a bunch of times as well. I have like a partial grid or whatever. But yeah, you do need some stronger constraint on the line than just the line is a 10 line in order to build the line for sure.
5 in this box because these are 2-cell 10 sequences. So if we were to put 5 into either of these dominoes, the other digit to add up to 10 would have to be 5 again, wouldn't it? And that means 5 is on the arrow. Now, if 5 is on the arrow and this is 8, this is a 1-2 pair that goes with the 5. So we get 8, 9. I'm almost sure that's going to be correct. The reason I really like the look of that is it would use 8 and 9 here. And their complements, if you like, in terms of dominoage that adds up to 10 are 1 and 2. So having 1 and 2 on the arrow is exactly where they should be, because they can't be in here. So the other option is that this is 9. And then if this is 9, we worked out that was 7, didn't we? Okay, but
this is the quintessential 10 line of experience of thinking like, okay, there's only 2 cases. I'm just going to work it out and figure out which one breaks, and then chasing both cases really far and figuring out that neither of them breaks. This just happens over and over again. And it's something whenever I watch people solve my 10 lines puzzles, I see people doing an awful lot of sort of trying both cases. And I mean, I can't blame them because, you know, it feels like something's going to break. And then it just so often works out like this, where it's like, wait, somehow both of these work anyway.
Oh, no, that's fine as well. That's weird. Okay, that's also fine. I wasn't expecting that. Because if this is 9, and we've got to have 5 on the arrow, it must be 1, 3, 5. And that means you have a 3 on this arrow, which is the complement of the 7 that would go there. So you'd have 1 and 3, which are the complements of 7 and 9, and this would be fine again. That's really strange. Okay. I don't know if I'm meant to do this, but I'm going to do it. That's definitely... These cells are definitely from here, and there's definitely a 1 on this arrow. Whether this is 8 or 9. So... Good, good grief. Okay, so it's all right. It's this digit that we have to focus on. That's very clever. Good grief. Right. This is not 9. And this is not 9 for, it's not even that easy a reason, but it's very beautiful. This is not 9 because what would happen if it is? And we have to look at this box to see that there's a problem. So maybe this is a sort of good Agad-Mator
This is definitely not how I saw this.
YouTuber who often says, pause the video, I'll give you a couple of seconds to see what's what if you want to spot the next move in a complicated chess game. Well, here...
I'm trying to even figure out what it is he's seen myself. Because obviously if that's 9, that's 1. This is 2, 3, 4. Ah, okay. And then the problem is now you've used 1, 2, 3, and 4. And so now this is dead because now these sum to at least 11. Okay. I see how he's seeing this, which is not that, as so often happens when Simon makes a step that I don't expect. It turns out that it's just sort of it's amalgamating 2 steps that I intended. So my intended step here was to mark this cell as 1, 2, 3, and note that you now have a virtual 1, 2, 3 triple because every 3-cell arrow has 2 1, 2, 3s on it. That's 1, 2, 3, and therefore these digits are now all of these digits are now at least 4. And so then you get to figure out sort of how the 10 sums have to work and all of this. That sort of breaks in all of this. So I definitely didn't, until after resolving stuff later, identify what was happening with the fact that this couldn't be 9.
Can you spot why this can't be a 9? For those of you who managed to do it, congratulations. The reason's really clever, because if this is 9, this has to be 1 to make a 10 sum. But look at this arrow now. How's that going to work? It can't have a 1 on it and it's 3 cells long, so it would have to be 2, 3, and 4, and then this would be a 9. That's the only way it could possibly be constituted. But now we have a big problem on the orange line, because we've got to make some number of digits here add up to 10. And we can't use 1, 2, 3, and 4 because they've disappeared from the box. So this is at least a 5, and this is at least a 6 then. So those are adding up to at least 11, and there's no 10 sum possible. That's just lovely. That's just lovely, isn't it? So that's giving us this digit. Well, not really giving it to us, but it's helping us this digit. Now, my first opportunity for a mistake I have just avoided. I was about to say this is a 3, but it's not, is it? Because this could be a 1-2 pair adding to 3. So, ooh. Okay, so that digit is 1, 2, or 3, but we have to be careful because this could extend. In fact, I'll start colouring it, but that one might be purple. There's probably something we can do on that arrow now, but let's go back to this box because when that was 7 by mathematics, this was 9, which means there is no 2 on this arrow. So we've now got even digits in the dominoes, so 2 8s and 4 6s.
I'm going to take a real quick moment to refill my tea. I'll be back in just a second. All right, I think we're back. There we go.
So if this was a 2, this would be 2, 8. This would be 4, 6. That's probably okay. Okay, simple point. That can't be 6, because a 6 arrow would involve this being a 1, 2, 3 triple, thereby effectively making this cell impossible to fill. So that is now at least 7. But all of the... If we think about a 3-cell arrow...
If there's a 3-cell arrow in a Zeta puzzle, it's almost always to make a virtual 1, 2, 3 triple. That is a thing I do a lot. Although I definitely traumatized Naverio with my one puzzle that was all using arrows to make virtual 1, 2, 3 triples. I don't know if that ever got put in an app or not. I designed it for a Cracking the Cryptic app, and Naverio tested it, and I don't know if it ever got used in like the Line app or whatever. But I used that idea a lot in one particular puzzle.
Arrow. Even if this is 9, this arrow must have 2 of the digits 1, 2, and 3.
Hey, Memrister.
Because let's imagine it didn't. If it only has 1 of the digits 1, 2, and 3 on it, then its minimum constituents would be a 1 and a 4 and a 5, and 1 plus 4 plus 5 is 10. So that doesn't work. So this collection of 4 digits contains all of the digits 1, 2, and 3, which I feel is somehow meant to be point. Well, yes, that is the point. Okay, so that's also telling me the nature of this digit. Because if this was a 1, 2 pair, then the minimum constituents of this arrow would be 3, 4, 5. And that's too many, isn't it? So this is 3, and it didn't extend here. And okay, so...
Hey, Playmaker.
Right, so now I'm going to use the fact this can't be 7, because if this was 7, this arrow would be 1, 2, and 4, and we'd run into exactly the same problem we were going to run into before when this was 9. Because if this was 1, 2, 4, then these 2 squares again have to be at least a 5, 6 pair, and that's too many. So that's not 7. So now it's either 8, and if it's 8... then it can't have 3 on it, so it's going to have to be 1, 2, and 5. Oh, but that looks likely, doesn't it? Because then this could be 4, 6 and work.
Yeah, I just my intended step is to corner mark 4 into those cells.
If this is 9, it's also very restricted, because then it can't have 3 on its arrow, so it's not 2, 3, 4, and it's not 1, 3, 5, so it's going to be 1, 2, 6. Right, so this arrow always has 1 and 2 on it. So now this... Is there any way that this... I feel like that's got to be...
It's funny how this gets you a quintuple.
Gosh, that was almost a sixth sense there. I was like, this has got to be 4, 6, doesn't it? But actually that's not true. It could be 4, 5. I mean, there must be a 4. in one of those squares. That's definitely true. Because if there wasn't, the minimum digits we could put in would be 5, because 1, 2, and 3 have been hypothecated to these 4 squares. And we couldn't put 6 in there. It wouldn't matter. 5 and 6 is too big anyway, but the minimum sum of these would be too big anyway. All right, so this is either 4, 6 or it's 4, 5, but we don't know whether this one is included or not. At least I don't think we do. There might be a reason we do, but I am not seeing it. So if that's 4, 6...
Yeah.
Oh, no, it's not.
I don't think I even used placing the 9 here. I just used that these are now from 7, 8, 9 to say there's definitely a divide. And if there's a divide between these two cells and the 10 line, then you know how it all breaks down. And then, of course, you know by Sudoku where the 9 goes and all of that sort of thing. But the virtual triple of the 1, 2, 3 is so potent in terms of what it does to the 10 line was
Sudoku.
Why I drew it.
How embarrassing. never one to overdo the Sudoku. Right, okay. Where does 9 go in box 2? That's a legitimate question. One could have asked probably about 25 minutes ago. I didn't see it. There we go. It goes there. And therefore, I've got, well, now 6. Right, okay, so 6 has been removed from this domino. So this is 4, 5. That is 1. So that's a little sequence. These squares are, okay, there's 7 and 8. Now, 8 comes out of there, so 2 comes out of here. 9 lives in one of 2 places in box 3. It can't go on the arrow, because this, if it's on the arrow, this is at least a 10, and that is not possible in this puzzle. Now, the other thing I was looking at was this. Because we know that's a sequence, we can't join these 2 together. They add up to 15. So this domino here is a 10 sum, definitely. Let's make it a different colour. So this square here is a 2 or a 3. Yeah, and then again, we've got to be careful with this digit. Because if that's an 8, then that is a 2. But if that's a 7, this could be a 3. Or, if this is a 7, that
definitely
could be a 1,
intended
2
microstudy.
So that digit is, I don't think, known to us. Or to put it a different way, we don't even know the length of this 10 sum. Let's use grey. It could go here, so we've got to be careful. Right.
What microstudy is saying is these 2 cells can't be a 2-6 pair, because if these 2 cells are a 2-6 pair, it breaks this green domino over here, which definitely has a 2 or a 6 in it. And the only way these aren't a 2-6 pair is if there's a 1 in one of the 2 of them, which means that cell surely isn't 1.
Now, what have you done now, zetamath? What have you done now? What do I do? Maverick is about to fly past. There were loads of planes in the air last night as well. I presume that's people who knew that the
It does eliminate
one
1 from row 1, column 8, which is very potent.
They were going to see it from the sky. Okay. I don't know what to do. Sorry, if this is obvious, I apologise. I'm not seeing anything. I don't know. I was going to say I think it might be this box, but I really am not sure. If this is a 1-2 pair, does that give... No, that doesn't give me a problem on the arrow.
It is true that
this arrow,
it's this arrow is the thing, which is not the first place that you're inclined to look at this.
Oh, good grief. Right. No, it isn't actually. That's vicious. That is vicious. zetamath. That. I feel quite lucky to have seen this. Because I only saw this because I was thinking about the fact that 1 couldn't be on. I can see very clearly that 1 isn't on this arrow. And I had the thought, okay, if that's a 2, 2 can't be on it. And that struck me as a little bit interesting, because then I could see that this was 6 or 8. Because if this is 2, both of those digits can't be 1 or 2.
Yeah, this arrow is placed just to corner mark a 2 on one of these 2 cells. That's the whole point why this arrow is here. I of course played with a lot of like, what are the ways I can draw an arrow that will force that, by using the fact that I've used so many low digits out of this column. And then it turns out, spoiler, this arrow is actually 422, which then ends up being hilarious at a later point in the solve. But it wasn't at all intentional when I placed it. I only placed it because it was the arrow that forced exactly that one of these 2 cells is 2. And so therefore none of the cells that see both of them can be 2. Which is used both at this step and is used at the next step as well.
Therefore, they could be double 3. Was my thought. So I was thinking 6 or 8. And then I thought, oh no, double 3 won't work because of that. But then I realised, oh, well, hang on, I've also got a 4-5 pair looking at this. So that digit, all of a sudden, if this is 2, this becomes at least 6, and that becomes at least 3, and that becomes at least 9, and it can't be 9. That actually is beautiful setting, because that, I cannot tell you how unrestricted a 2-cell arrow normally is when these 2 digits on the arrow don't see each other. So you can't even say they have to be different. That is weird. And it's a beautiful idea, though, isn't it? I'm just trying to think about that from a setter's perspective. So zetamath has noticed the possibility that if this is 2, these 2 digits are under significant upward pressure. And then notice this digit would also be under that pressure. Once you have the idea, you can't leave it. You can't not do that. But having the idea is the genius. That's lovely. It's just lovely. Right, and what does it mean? It means this isn't 2, so that's 3. It's probably not going to do very much, but well, no, it has done something, because now we can't. This cannot extend, because we need 2 more, and we can't split that up into double 1 along
No,
this
not a cigarette.
line.
It's just a pen I'm playing with.
Now, now what do we do? What's that actually done? Yeah, that's what it's done.
It has done something.
It's got rid of 2 and 8 from this. So this is now. Whoopsie. No. That's
the ye old 2, 6, 10 sum.
Right, so that gets me a 2 here and a 1, 6 pair. These squares.
Animal Well is what I'm streaming tomorrow.
Can't put 9 in the thingy. Actually, I've seen what that's done as well. That's beautiful. I'll come back to that in a second. Let me just do Sudoku a bit more.
I used this step in a tutorial puzzle for arrows that I really liked it. So I was really happy I was able to reproduce the same idea here of using this arrow in this way that it's about to be used, because it made me happy inside.
Or not. No, I'm not. I'm so appallingly bad sometimes. There must be something going on here. I can't see what it is, so I'm going to do what I saw up here. If this is 9, what's this digit? And because this is 4, 5, that also would have to be a 4, 5, wouldn't it? But we know there's a 4, 5 pair in these squares, so this cannot be a 4, 5 arrow, so that cannot be 9. And that's actually really good, because that's going now, by sort of arrow logic, we must have the higher digit. So that must be must do that by maths. Now that's good, because that gives me another digit here, and that gives me a digit here, digit here, digit here, digit here. Here we go. Right, this is a 7, 8 pair now. These
this whole
digits
moment
are
just
3,
baits you
6
into having
now.
optimism that things are about to get
So we'll have
easier.
a look at this 10 cell in a moment, but let me just see if we can do anything else that's more straightforward. I can see something here as well.
My hope is that Simon spent enough time talking about the 2-cell arrow having a 2 on it that he'll remember the 2-cell arrow has a 2 on it
There's
when
a
he
few
needs that in a
things to
second.
look at now. I'm not sure which is the one that's the most urgent. Let's try this one first, I think. So let's join those up together. Oh, that's a horrible choice. We'll go back to green maybe. Now, obviously, this might be many cells long, although it probably can't be that long because 1 and 3. No, yeah. Given actually that we can't put 1 in this sequence, this is either a 2-cell or a 3-cell. That's all it could be. But it could be 3, 2, 5, couldn't it? So I think it's definitely got the possibility of being a 3-cell sequence. Yeah, it's under more pressure if this is 6.
I badly wanted it to be 325, I will confess. I tried everything to make it 325 and had a really great clue that made it 325, but also broke the puzzle, which was unfortunate. Because you prefer the puzzle to continue to have a solution. But in the end, I had to relent.
6, because if this is 6, this has to be 4. Because 1 and 3 are not available to make the extra 4 up because of this. So if that's 6, this is 4. If it's 3, well, 7 would work straight away in a domino, but it could extend. So if these two digits had to add up to 7 to make the extra 10, or to make the 10 total if this is 3, we couldn't be 1, 6 or 3, 4ing, so we'd have to be 2, 5ing, and it would have to be 2 here by Sudoku. Okay, alright, I'm now fairly convinced this wasn't what I was meant to do next, because that doesn't feel like it's under enough pressure.
This is the step that Tristan got stuck at when Tristan was solving this on stream. So what I intended was, if you put a 6 here, you put a 4 here, and you've now burned every low digit in row 4. Because remember, there's a 2 corner marked in this, so neither of these cells can be 2, and now you've created exactly the situation that Simon was talking about at the beginning, where you've got 2 cells that are on a 10 line in a 10 sum together that cannot be 1, 2, 3, 4, and that just instantly breaks. That was what I intended. I think it was maybe sneakier than I intended it to be. I think in my mind, the 2 corner marked in these 2 cells stuck out more than it did in the mind of the typical person solving the puzzle. But that was why I was thinking about it.
Okay, let's. I'm just going to talk about the thing I noticed here.
The thing with even digits in box 4 was definitely intended.
Which is this. Because 1 is not available, that clearly is not a 4-cell sequence summing to 10, because the only 4-cell sequence that can work if the digits see each other is 1, 2, 3, and 4. Now, it can't be a 3-cell sequence either, for an interesting reason, which is that the only 3-cell sequence that does add up to 10, if you can't use a 1, is 2, 3, 5. And that will break that square. So this feels like a zetamath thing.
It probably goes without saying, but the way I set this is that I started with that end and just knew I had to join them eventually because I knew there was only going to be one 10 line in the grid. And then I was disgustingly lucky that I was able to make these line ends connect eventually, although you can see they connect in a kind of ugly way that is a little bit unfortunate. But I was willing to accept it.
Because what we're now learning is that is a domino that adds up to 10, and it's not 1, 9, and it's not 2, 8. So this is either 3, 7, or 4, 6. Now, can we do better than that? And the answer is no. No is the answer. Although, if that's 4, 6, and that's 4, 6, 4s and 6s would be down there. Oh, but it's sort of symmetrical, isn't it? If that's 3, 7, then that's 3, 7, and we get 3 7s down there. So whatever this is, it has quite a lot of effect on box 7. Okay, let's try this little arrow then. But the thing is, it's weird. The availability now of 2. You see, 2 can go in both those positions, so this can be pretty minute. So we can have double 2 equals 4. If we don't have, well, we can't not have 2 on the arrow. We've already worked that out. So 2 is in one of those squares. That feels like a point. 2 is in at least one of those squares. No.
His Zeta Dar is good to know that was what Zeta wanted you to say.
That feels like it's operating on this cell the most.
Oh wow, yeah,
we're rotate that square.
We're getting
that
right there.
Square is 4, 5, 6, or 7 by Sudoku then, because whichever one of these is 2, they might both be 2, but it doesn't matter which one of these is 2, and that's seeing that square. This already sees a 1, 3 pair, and it sees an 8, 9 pair, so that's quite big.
There are two sorts of Simon solves of Zeta puzzles. There's the Simon solve where he does everything exactly the way I intended in the exact order I intended, and the Simon solve where he does something in a completely different direction. The exactly is more common, but we're definitely here in the exactly what I intended, exactly how I put all of these lines into the grid path, which is always very satisfying to see. Something Clover likes to call it communication, when someone sort of sees the exact thing that you intended the way that you thought about it.
If that's not 2, it is whopping then, because it's at least 6. So that would push this. That, in fact, okay. So if that isn't 2. If this digit is not 2, what could it possibly be? And because it can't be 3, 4, or 5, it's actually got to be 6. And that's because this can't be 1. Because if we push this up to 7, we know this is at least 2, and that's going to make this at least 9, which it can't be. So that digit is restricted. It's only 2 or 6. And if it's 6, this is 2. But if this is 2, then I think all bets are off. This can't be 3, so it would be a 4.
We're getting to the step Sweet Blues. Wasn't sure if it was intentional or not.
That can't be 7 either. Yeah, I'm probably going to just list out the options for this because it's intriguing me, and I can't quite see how this is. How few digits this can be. So if this is 6, we know this is 2, this is 8. If this is 2, this could be 4, I think, which would make that 6. If it's not 4, it can't be 5, because that would make this 7, which it can't be. So it's going up to 6 again, which is the most it could be, because we can't make this bigger than 8. Oh,
I do like to pencil mark things.
For goodness sake, that is beautiful. All right. Okay. I can see something very, very simple there then that just kills this. Again, it is an Agad Meta moment. This is so beautiful, though. This is so... I want to say simple, but that doesn't do it justice, because it's not... It is simple, and when I tell you what it is, if you haven't seen it, you will go, oh, of course. But it's just beautiful. It's so elegant. In fact, I will tell you this for nothing. This tiny little arrow here and this tiny little arrow here are doing ethereal work. in terms of this Sudoku. Because now I'm going to tell you, this is not 4-6. Because if this is 4-6...
Yeah. Chat has noted Simon said that this circle could be 4, but then did not write a 4 in it, which is going to create a problem later when it turns out that the circle is 4. So there may be a bit of a pants-shitting moment later when Simon works out that this arrow can't actually be 6 or 8.
Those two digits, I haven't worked out whether they even work, but I can see they're both even. And if they're both even, all the even digits have gone from this box. How on earth can you make this work? That's 3 odd digits, but 2 of them are being added up. So that's got to be even, and it can't be. There's no way you can constitute a 3-cell arrow with only odd digits. It won't work.
So I realized this, and I knew I just had to put a 2-cell arrow into this box. So I experimented with an awful lot of different 2-cell arrows to find the 2-cell arrow that I liked best. But this exact observation that I can't use every even in the box was exactly what I intended. So I'm glad that Simon spotted that seemingly instantly, actually. That was the point of all of this story.
So I think it's parity that's telling us that this is 3-7. Right, and look, that's doing work. So now we know 3 and 7 are down here. We're heading for 3 in the corner. Oh, golly, what does that mean? 9 is a bit restricted in this box because it can go in this, it can't go on an arrow, so it's in one of 2 places. It might be, is it this continuation or not?
Not marking row 6 column 3 as possibly being 4 is going to be a problem.
Benefit from some thought. Let's think about that. If this is a 2-cell sequence, it can't be 1, 9, 2, 8, 3, or 3, 7. So it is 4, 6. Now, why is that a problem? I don't know. But if this is a 3-cell sequence, I mean, it might even be able to be a 4-cell sequence because these two can be different. The minimum sum of these is, I suppose this is a minimum sum of 2 and 4, isn't it? Which would be 6. But that could be a 1. Oh, and then we get, and that could be a 2. Yeah. Oh, good grief. Oh, no, I was thinking maybe even we could extend and become a 5-cell sequence. No, but we can't do that because that really will break these 2 squares. So 2, 4, 1. Now, it's a bit weird because there might be a restriction here from the point of view that you can't increase any one of the... you can't increase any of the digits by exactly 1, which is what I'm trying to do to make it work. I mean, I think if it does go there, that has to be a 2. I'm very sure about that, which would mean these 3 squares have to add up to 8. Which means one of them has to be a 1, which has to be this one, which means this has to be 2, 4. Sorry, that doesn't work, does it? Not 2, 4, because they don't add up to 8. In fact, there's no way to make those 2 squares add up to 7. That's weird. So, okay, so it's not a 4-cell sequence. So, is it a 3-cell sequence? Because otherwise it's 4, 6. Could it be a 3-cell sequence? But the thing about a 3-cell sequence is that can be 1 or 2. So, what could we have there? We can't have 2, so we can't, these 2 can't add up to 9, because 1, 8, 2, 7, 3, 6, and 4, 5 are unavailable. So this would be 2. These, see, I just don't think this works. I think this might have to be 4, 6. But I'm sort of terrified that I'm missing a point here. Again, I feel a bit like, where was it? I can't remember. There was somewhere up there where I felt like I was making a mistake. And I feel like I'm making a mistake, even though I think the logic is telling me that this is 4, 6.
Think about row 4, Simon. If you think about row 4, it will all become clear.
I don't know. I'm going to have a look. I'm going to have a look at... Is there something else that's easier? Is that become easier now? No. No, that's nonsense. These 2s, I was just wondering if I could... That can't be a 2, but this could be a 1. Yeah, okay, that circle is being pushed up a bit. Not much, but it can't be a low number, I don't think. Because the lowest this could be would be 3. 3 won't work. This can't be a 1, 2 pair. It can't be 4 because this can't be a 1, 3 pair. It can't be 5 by Sudoku. Now, could it be 6? Only just. It could be 6 if this was 1 and this was 5. That's just possible.
This is also a good step for him to do. Because this
Can't
will
be
also
7.
get him a digit.
Now, if it's 8, what happens then? Because if it's 8, 3, 5, and 1, 7 go away.
And 2, 6,
if it's
8 is
8,
not
this
going to
is
work.
2, 6, and that doesn't work. Right, it's not 8. So can it be 9? I've got 9 pencil marked in here, but I think that was Sudoku. I don't think I thought about the arrow. Now, if it's 9, this has to be 1, 8. It has to be 1, 8. Right, so that's always 1. There you go. That's a deduction. That is always 1.
That's the step I put in for Tristan, because Tristan loves that that kind of deduction of the, like, oh, there's 2 possibilities here, and they both involve this being a 1.
And this is either an 8, 9 pair or a 5, 6 pair.
Oh, I bet
5,
saying
6.
the phrase 8, 9 is going to get him there.
No, that's still okay.
It was
got
plonk
Right,
time,
beautiful.
DM. You can thank plonk time for it.
That is not a 5, 6 pair. Okay, and this is okay. I'm more comfortable with this deduction than I was down here. I might turn out to be right down here, but I felt worried about it. Now look, if this is 5, 6,
I do like
where
that
do you
this is another sort of path. If you don't realize you can do the trick with the counting the low digits in these cells to resolve this will sort of tell you, hey, if I make these 5, 6, I have to put 8 and 9 in row 4, and that's going to be a real problem.
8 and 9 in this row? And the answer to that is it's tricky. You can put one of them here, but one of them has to go there. And I don't think that can be an 8 or a 9. Because what am I going to join it to? I can't join it to this, that's far too large. And I can't join it to that, because that's part of this domino and adds up to at least 5. So there's no way that works. So this must be the 8 and the 9. That's at least a thing we have discovered. Now that being 8 means that's 6, which means that can't be 6 as well, doesn't it? So that's now 2, that's 4 by mathematics. That's 8, that's 2. This might do it. I shouldn't have said that. I don't know why.
This might do it.
Yeah, no, I've made a mistake. Sorry. Oh, that's so ironic, and so I was so.
At least it broke instantly.
I so deserved that. Oh, hang on! Look at that. I've seen a way that this can be a 4. Like, why can't that be double 2? Did I use that for anything?
That's the terrifying moment whenever I notice something like this. Is, wait, did I use that?
No,
this?
I've got lucky there. Well, I did use it a bit, because when I said if this was 4, 6, these were both even, and I'd have used all the even digits, that still would have been true if I'd written 4 in there, wouldn't it? But I got lucky because I didn't see. I think I did see the possibility of that being double 2 at one point, but I didn't pencil mark it properly. So, but this is good. It's good because now if that's because the puzzle might still work. This is why it's good. So that's 8. That's 2. Now, are we saying basically that by hook or by crook we have proved this is a 4? I think we probably are, but let's see if we can do it in an elegant way.
Yeah, just ask where 2 goes in the box.
If this is 6, that has to be 2, that has to be 4, and there's nowhere for 2 in the box. That is quite elegant. I quite like that.
Yeah, you could even simplify it a step by just asking where 2 is.
Potentially exactly what zetamath intended. So now this has to be double 2 by mathematics. So that is not 2. That's probably going to do something to that domino. These squares are 5 and 6. Oh, we can do it. That's a 6. That's a 5. So now what's down here? 3, 7, and 9. And what's down here? 2, 4, and 6. Yeah, this is looking like it's going to be a 4, 6 pair, isn't it? And this down here is 1, 8, and 5. Oh, look down here. In this column, I've got all the low numbers now, so these are all massive numbers, right? So what we should do is work, but these two can't join together because they would add up to more than 10. So this one has to go backwards along the line, and it can't join up with 8 or 5, can it? Because it's going to break the 10 boundary. So that has to be a 1. I don't know whether it joins.
Yeah, I had intended the line to move only orthogonally, so I had never intended there to be a 5, 5, 10 sum in this. But yeah, a lot of people, when they looked at the grid, their first reaction was, well, there's only one spot in the puzzle a 5, 5, 10 sum could be, so it had better be there. And then they were disappointed when that did not work out.
Joins here or not, but it definitely... Yeah, no, this has cleared up all of the potential confusion in this part of the grid, because we can't extend this any further. We know that this is at least a 2-cell sum, but we know those two are sort of tied together by an indelible ligature. So given these two are tied together and the sum of those is at least 7, and these two are tied together and the sum of those is at least 6, they have to live independently from one another. So that's got to be 9. This is a 4, 6 pair. This is, I didn't work out before that's a 2, but that's what it turns out to be. So these digits now are all smaller than they once could have been. That's not a 9. And we can, well, that digit's got to join up with something here that can't be too big. So that's 1 or 4 only, because it can't be 2 or 3. But be careful, because we could be going here as well, couldn't we? If this was, say, 613 or 712, no, 712 wouldn't work. Oh, in fact, that's weird. So that can't be 7, can it? Because if that's 7, what on earth do we pair it up with? We'd have to pair it up with 1 and then 2, and we can't, so that's not 7. So this is even. Oh, much simpler. This can't be 8, because 8 would need a 2. This is a 6. That's so weird. Okay. Oh, goodness. All right, so that's good. Don't know what it means, but it's good. I still don't know whether this goes to be 3 cells or it just sticks being 2. Have we resolved this now?
Now probably there's enough digits filled in that realizing that definitely can't be a 4.
4, 5, 6, and 7. Okay, so we know those two add up to at least 7 on their own, so we can't join it to this one. That cannot work, can it? because it would add up to at least 11. So these have to live independently. Oh, no. So they're either 3, 7 or they're 6, 4. Both of which seem to be entirely possible. Ah. Oh, but that's gorgeous, actually. If this was a 4, if this was 6, 4, this domino couldn't work, because these digits would then be at least 5 plus 6. Oh, that's lovely. So we've got to go the other way. That's got to be 3. That's got to be 7.
I'm glad you can do these sorts of pieces. Like there's two pretty hard pieces here, the box 4 stuff and the box 6 stuff, but you can do them fairly independently. So in this case, I did that side first. But if you do that side first, it works out. And so that's a little bit nicer to the solver, that they can sort of do this either way.
Oh, and now these can just live together in harmony, can't they? They could just be a 4, 6 pair. In fact, they probably have to be a 4, 6 pair because that digit's too big. If this is a 3-cell sequence, this is at least a 4. Yeah, there you go. So they have to be a 4, 6 pair. This has to be a 5. 7 and 8 get filled by Sudoku. This is a sequence. Make it blue. No, I'm going to make it yellow. So this one is, well, these two are together with possibly more, but
It is a very long line.
Don't know. Oh, no, I do know. I do know.
There
Look,
we go.
Look at this domino, because it's very pretty. This can't be a domino, because there is
this
no
is one of
10
my
fill that
favorite.
work.
This is one of my favorite 10-line steps, which I guess isn't terribly surprising since it's like the first step in the first 10-line puzzle. But I do this a lot.
1, 9, 2, 8, 3, 7 would kill that one, and 4, 6 doesn't work. So it's at least a 3-seller. Now, if it was a 4-seller, can it really be a 4-seller? No, because this is too big. If it's a 4-seller, this is at least 4, and these squares can't include 2, so they would be a minimum of 1, 3, 4. So we'd be adding 8 to 4.
So I will say, in my mind, there was this really beautiful step in this puzzle at this point, where you had to realize that this 10-sum here, this 3-cell 10-sum, could not be 3, 4, 3, because if it was 3, 4, 3, it would break this 3, 7 domino, and I was really happy with that step. However, it can't be 3, 4, 3 because there's literally a 3 in the box, which I at no point noticed. So the very beautiful deduction that I thought I built in at this point got completely ruined by people looking at the box. There's a good chance that some solvers like me won't notice that there was a 3. But definitely it was intended to be a sort of neat way to do it.
4, and we're getting more than 10, aren't we? So we actually know the length of this. And we know that it's not got a 2 in it. So do we know it's got a 1 in it, is the natural question. Well, we do, but you have to be a bit careful with that. It has got a 1 in it, and that 1 is here, because if it didn't, how could it work? If it's not got 1s or 2s in it, the minimum digits are 3s and 4s and 5s. Well, they can't all be different, because 3, 4, 5 adds up to 12. So you'd have to repeat a digit. Now, you can't repeat the 4, because double 4,
Oh my God, is
adds
he
up
going to
to
do
11. But you could repeat the 3 with double 3, 4, except that's going to break
Oh my
those
God.
squares.
Yes!
And also that one, I now notice. Right,
Amazing!
So this has got a 1 in it, and by Sudoku, that's here. So these two add up to 9, and they are not 1, 8, 2, 7,
that
or 3,
is amazing.
6. So they are, oh weird, they're 4, 5.
Oh, Lord.
And we know the order. Okay, well that's something. This is a beautiful puzzle, isn't it? It really is beautiful. Now, where's 7 in box 5? And the answer is, I don't quite know. But it's in one of those squares, so that's fixing that.
Strange minds think alike.
So now there's a 3 by Sudoku here. That's an 8 by Sudoku. That's 2, that's 9. And we do that box without having to worry too much about it, except I made a mistake again, because now I can't put 3 in this row. What did I do? I've got 2 4s in this box. What nonsense have I propagated here? Sorry. How did I do that? In fact, that's a 6 I'm now seeing. I don't know what I did then, but whatever it was such utter nonsense.
He said that he was placing a 3 there, and then placed a 4 there
3
instead, which is
I might have tried
common...
to type 3 and typed 4 instead. That's possible, because I'm seeing 3 has to go there. That is still 8.
And this is how you know that Simon doesn't use a number pad, because if you used a number pad, you wouldn't misclick a 3 as a 4. I'm so glad that he saw the intended 3-4-3 step and did it that way.
Yeah, and these are 2 and 9. And now I have, I think what I did was I misclicked this digit. I might be wrong, but that does seem to be what happened. So that's 9 and that's 6. That's 8 now. And we can do a bit more.
I don't think Simon ever uses a number pad.
In this column, 1, 4, and 5 to go in. So we'll put the options in and see what we can do. And what about this? 2, 3, and 7. Oh no, that can still work. Oh bobbins. Okay. So all right. Well, it's going to be this little line segment, but I think we've got to go full ham on the pencil marking now. So 2, 7, 9 here. 1, 4, 6 here. Now, what's breaking? And these are 3, 5, and 8. With that not allowed to be 8. So
God, number pads are like
$20,
and they're like the nicest quality of life thing ever. I highly recommend it.
So that is a 3, 5 pair. 3 and 5 add up to 8. That's not 10. So we need 2 more. So that's a 2. That's a 7 now. So that's 7, 9, 2. Now that's 9 by Sudoku. This is, it's 7.
Well, I think you want a separate one because it goes on your left hand, and you can use your right hand for a mouse if you're right-handed.
Now, is this... I've got a 4, 6 pair here, so this is 5.
Coloring here would probably make clear what's happening.
3. Oh, right. Yeah, okay. Because that was a sequence that added up to 10, let's make it green.
But yeah, it's incredibly awkward to use the one that's on the side of a...
It has to be that way round to make the mathematics work. So we can finish off all of our 10 sums now, which we should do. I haven't been using orange, although on an orange line that's forgivable. Let's make that grey so that it doesn't clash. Right, there we go. So hopefully we're there. 5, 8, 8 here. 4 here, 6 here.
Oh no.
1, 4, 6 there. What a beautiful... Oh no, I messed it up. I've got 2 6s here. Is that just a slip of the... I've got 2 6s in this box. I will double check it because I don't like that. What have I done there? Look, I've gone there and then I've written 6 in there. Did I mean to write 7? I did mean to write 7. Oh dear, dear, dear.
Then he tries to write 6 again.
I've had a peculiar number of what feels like misprints or misclicks today, which is most distressing. 4, 6, 1, 6, 4, 8, 5, 8, tick. Phew. Gosh, nearly 200 people have done that. This has been out for a month, apparently. I didn't know about it. That's remiss of me. But that is a beautiful puzzle, my friend, as usual.
Now the colors are gone.
You never let the community down, zetamath. You just produce stellar puzzle after stellar puzzle. And that puzzle, 10 sums. We have done a lot of puzzles with 10 sums. You may think sort of 10 sums have been exhausted, but no, they haven't. That was lovely. And there were some moments of absolute sublime brilliance. My favourite... Well, my favourite actually was these two arrows. They are the most ridiculously beautiful. This one and the parity point was sensational, and the fact that this existed at all was sensational, because it had no right to. It had no right that this arrow helped with this digit, and yet it did. Yeah, that's brilliant. Let me know in the comments how you got on. I enjoy the comments, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.
Well, thank you, Simon. That was a very nice solve. I'm so glad he got all the intended steps, including the 3 + 4 + 3 step. I am really delighted. Like, he might be the only person on Earth who also gets the 3 4 3 step not working. So awesome solve there. Let's see. What are the? I'm curious what the comments say now that we have this. Me yelling from the future that the arrow could be double 2. Oh, you also did it, Playmaker? Oh, that's awesome. That greatly amuses me. Oh yeah, I do often use the pen tool as my way of marking 10 sums when I'm solving / setting. That is a common thing. Let's see. Let's see. What have I done there? I did mean to write 7. Write 6 again immediately. That definitely did happen. Let's see. Yeah, the number pads are so nice. Someone send Simon a number pad. I think Simon does this enough to do this. Alrighty, well, thanks for joining me today. As I mentioned, we're going to have a normal time stream tomorrow, although tomorrow's stream I'm going to stream Animal Well instead of puzzles, so that should do that. But anyway, thank you everyone for hanging out. Excellent. And yeah, we finished in time for the 2 minutes for Meme Rister to do the new video, which is premiering. So that's awesome. Glad to do that. But thank you everyone for hanging out. I've had a great time, and I'll see you all tomorrow. Have a great time. Bye for now.